I'm an Android engineer at BlaBlaCar, and today I'm going to present you our experience migrating one of our apps from Autovalue to Kotlin data classes. Before we get into the migration process itself, let's just take a quick look into what is Autovalue and why we decided to use it to begin with. So here is a simple, harmless user class. And we can typically call it a value or content class because we're interested in its contents. And if that is the case, there's a number of things we can do with this class to make sure we use it properly in Java. For example, we can make sure that the class is annotated with final and its fields are final as well, so we ensure that the contents are immutable. If we do that, we need to make sure we have a constructor to construct our class. Okay, this one is falling behind. Sorry. Okay. So we need to have a constructor to ensure that our class can be accessed properly. We might also be interested in annotating fields that are nullable with a nullable annotation. Since we're interested in the contents, we may as well, we should also add override equals and hash code. If you're using Android Studio or IntelliJ or most modern IDEs, the IDEs can generate this code for us, but we still need to manually go into the function that generates this code and add it to our user class. Again, if you're using parcelable on Android and we want to have our user class implemented, we need to add the implementation for parcelable. We need to expose the right getters for the content that we want to access. If we want to change some of the contents, we probably want to add some kind of function like this to copy the contents to a new instance of our user class, and so on and so forth. And in the end, what we get is this huge class with a lot of boilerplate code just to make sure that the contents of our class is properly handled. And that's not all, so there's a lot of things that I didn't add to that code. So if we want, we could also annotate the non-null fields. We didn't add the tree-string implementation to that class. If we remove or if we add a field, we need to ensure the consistency of the implementations of hash code, of equals, and so on. If we are doing serialization with this class, we need either to write our own custom adapter or rely on reflection and repeat this for every new class that we want to behave the same way. What is the solution? So one of them is Autovalue. And Autovalue is a library by Google, which basically addresses all of these issues. And it automatically generates these boilerplate code for us. So it can generate equals, hash code, toString, and so on. And it has a powerful plugin system that we can add other dependencies to make sure that these other kinds of boilerplate code that we need on Android is also generated for us. Why use it? So this is from, why this? Sorry. Okay, I think now it's good. So why use Autovalue? This is taken from their GitHub page, so these are the reasons that they explain. If you follow that link later, they have also a presentation where they explain more details about the advantages of Autovalue over different solutions. Basically, there are no runtime dependencies. Every time is generated at compile time. The API is invisible. The class that is going to be generated functions like any other in your project. There is very little cost to performance since everything is done at compile time. Your class is mostly like any other, so there's very few things you cannot do with it. There's then very little magic that is happening behind the scenes. So how does it work? Well, basically, you annotate your Autovalue, your class with Autovalue. I really don't know why this is. So you have what you have to do is have an abstract class that you annotate with Autovalue, and the fields now become abstract methods. And so our previous class that we had fields for the values that we're interested in, now they're abstract fields, and the ones that are nullable we annotate as such. And behind the scenes, what Autovalue is doing is generating this code for us. So this is not us writing this anymore. So all the no checks, all the hash code, all the equal implementation and so on is generated by Autovalue. So it takes that burden from us and it's done automatically through an annotation processor. But now, since this is an abstract class, we need to somehow expose a way to get an instance of this class, and we do this with a static method. Typically, you can also use a builder pattern if you want, so Autovalue provides that for you as well. Here, to simplify, we have a simple create static method that then, behind the scenes, we are returning an instance of this Autovalue underscore user that Autovalue created for us. In addition, there are these plugins that I mentioned before. So Autovalue has this powerful plugin system that you can basically add more things to generate code for you for your class. In our project, we use these three. So Autovalue Gson for serialization, and Autovalue parcel for the parcelable implementation. And with these plugins in place, all you have to do is add the header of the things you're interested in. So for parcelable, you just have to say that your class now implements parcelable. For the transformations that you want to change some fields, you can annotate them with this with method. And for serialization, you have to add this static type adapter function that returns the type adapter that was generated for you by the plugin. What Autovalue is doing now is creating these 4 different classes. So these are all extending from one another. So if you look behind the scenes, what Autovalue is doing, so there is one first class with the $3 that extends from our original user abstract class. And this is the original Autovalue generated code. Then you have another one that extends from the previous that has the Gson type adapter inside that was also generated by the plugin. A third one, which is for the with transformation that we have. And finally, the last one, which handles the parcelable implementation on Android. So this is all now generated for us, and we don't need to bother with creating this code anymore. So we just have this abstract class with the content that we're interested in. There's very few extra annotations that we need to add to our class, and we get all these code generated for us for free. And if we have that, why migrate to data classes then? In principle, since we have this class now in Java, and if we are migrating our project to Kotlin, we could just have Autovalue in Kotlin. The reason we migrate to data classes is because, well, they are a native answer to value classes. So data classes already out of the box give us pretty much everything that Autovalue does as an external dependency. So if you're using Kotlin, data classes generate equals hash code and toString for you at compile time. So you're not doing an annotation processing step anymore. This is done during compilation of your Kotlin class. And you get extra stuff. For example, copy replaces our with function that we had, and it's more powerful because it's much more flexible in what kinds of contents you can modify. And you also get the structuring declarations, which is this way of assign your object into different variables straight away, which is quite useful, for example, if you're chaining Rx operators or in Lambda declarations in general. So what we get is, comparing the two, is that with data classes we have less external dependencies. The code is much simpler, much smaller. It's just one line of code instead of all these fields and this abstract class that we have. We don't need an abstract class anymore, so we get our final class. We don't have an annotation processing step happening because this is done by Kotlin at compile time. And we had a few smaller plugin issues as well that we don't get anymore with Kotlin data classes. So with the plugin, just briefly, well, there are yet other dependencies in our code, so they are not provided by Google, they are not part of Autovalue itself, so they are the other libraries by other developers that, if we're using them, there are other dependencies that we need to make sure we keep up to date. The with for every little configuration that we have for the data we want to change in our classes, you need to provide a new method for it. That's how the plugin works. So if you have many transformations, that can become quite an extensive list of with functions in our class. And in case of Gson, in our project we use Gson. You cannot use the field name policy. You need to annotate all your camel case fields with the snake case version if that's what your API is returning. So in other words, what we're doing is moving from this, which is the Autovalue class in Kotlin, so to this, which is a much smaller, concise version and simple that gives us pretty much everything that Autovalue gave in Java. This is not to say that Autovalue is not good. By all means, it's very good if you're using Java. Just that if you're moving to Kotlin, data classes offer a much better way to achieve the same result. Two things to say here. First, we are using a parcelize plugin, which is Kotlin's answer to parsable implementation. What is different here in this plugin is that this is a compiler plugin. So again, there is no annotation processing happening here, and you can see this on Android Studio. You can go to Tools option and show the Kotlin bytecode, and if you press the decompile button, you get this, which is our data class decompiled into Java, and you can see everything that we had in our Autovalue generated class, so all the null checks, all the equals hash code, and so on, and the parcelable implementation. And this was done at compile time by the parcelize plugin. Another thing to say here is that we are using Gson, and Gson doesn't have Kotlin support. And so if we just have this class as it is shown here, and we are trying to parse the content from a Gson response, what happens, for example, if login is not present? Gson doesn't know about non-optional and optional fields in Kotlin. So what it's going to do is assign null to this login field anyway, even though in Kotlin this is not an expected behavior. So what happens is that the program is going to fail later. It's still going to parse, it's still going to work as a parsing result, but once you need to use that field later in your code and you don't know exactly where, this will fail in some unexpected ways that you're only going to notice later, or you might not even notice depending on how your code works or which kinds of fields are having null values assigned to them. Which leads us to our next step, which is, so how do we handle serialization? Well, we were using Gson before, which is a classic, and it worked well for us until now. There is Moshi as an alternative, which is faster than Gson, doesn't have many of its quirks. It's a smaller library as well, so in general it has advantages over Gson. And more recently, I don't know how many of you attended the talk before lunch where this was shown as well, that more recently the new version of Moshi also has a code generation for creating the adapter at annotation processing time, so you don't need to rely on Kotlin reflection, which is quite a big library. And so Moshi comes with Kotlin support out of the box. Well, for us, we had Gson all over the place in our code. There was an alternative. So there is an extension from this author, which is a library called Autovalue that works on top of Gson and generates the adapters for us. Moshi has a similar solution if you're looking at an alternative from what Moshi provides, which is called Kochi, and they all work similarly. So Autovalue, all you have to do is annotate your class with the Gson constructor. And if you have any snake case to camel case conversion to do, you can do so with serialized name. Kochi works similarly, so you annotate it with Gson serializable, and the camel case or the custom names that you want to change from the response, you also can set up this way. However, there is a third option that we looked into, which is newer and is also provided by Kotlin, which is Kotlinx.serialization, or we're going to refer to it as K-serializer here. And K-serializer, in principle, works similarly as the other two solutions. So you basically annotate it with serializable on the constructor and custom fields with serial name. But two things make Kotlinx.serializer more interesting. First, this is a compiler plugin. It's not an annotation, there is no annotation processing step here. So this is the compiled, our compiled user class, and you can see that the serializer annotation added this serializer field to our class at compile time. And the second thing that is interesting is that this is multi-platform. So if we look quickly at the source code of the K-serializer, we have this at the common, we have this interface at the common level, which is independent of platform, which is this interface expecting a serializer in our class. And note the expect keyword here by Kotlin, which is it's a way to tell the compiler that we need to have a platform-specific implementation. And if you look at the GVM part of the source code, so we have the actual implementation of this function that returns the serializer that was compiled in our object for us. And you can see an example of this in this app by Jake Wharton. That is an example of Kotlin multi-platform that does search on the Android SDK, both on Android and as a Chrome extension, I believe. And it uses Kotlin serialization as well as coroutines and Kotlin multi-platform. So it's an interesting example to look at. All right. So we looked at these three. There are others, but these two were the more likely candidates to transition from Gson in our case. They all had issues with the field name, so we can't have a general field name policy assigned to our classes, so we need to use this serialized name, this custom transformation for fields that use camel case in our project. And ultimately, K-serializer looks very appealing. It's multi-platform, doesn't rely on reflection, it's a compiler plugin, has more flexible adapters. And when we first looked at it, was it faster? We wondered. And when we first benchmarked this in February, turns out it was not, by a lot. We build on top of this work by Zach Sewers, sorry if I'm pronouncing his name wrong, where he benchmarked other solutions, but not the K-serializer. So we added to it, and it turns out at the time it was 3 times as slow in some cases. So our solution at the time was to use reflection plus Gson value where it made sense to use it. Since we control our API, we knew where we could rely on reflection from JSON. Today, however, looking at this again, so we ran the same benchmarks again, and we can see that the folks at Kotlin did a lot of work to improve the performance, and they're basically just as fast now. So there's basically no much of a difference between them. And if you look at Autovalue just out of curiosity, you can see that Autovalue adds a little bit to the performance, but it's not by much. So Autovalue doesn't, if you're looking at Autovalue for performance, that's not necessarily, you're not going to have much of a gain there. All right, so now we have all the information that we need to actually do the migration. So we know that there are advantages to using data class, and we know it can help our project, simplify our project. However, migration at first didn't look as trivial, because if we just use the conversion tool from Android Studio, we get an Autovalue class converted to Kotlin. And then there's quite a tedious process of renaming the fields and the methods manually to data class. Which, when we first tried this, turned out to be quite annoying, especially because the Java classes that we had that used those model classes, we needed to rename those manually to prefix them with a get, because from Java, when you access a data class field, we need to call get user name, get age, and so on. So what did we do instead? Well, we wrote an IntelliJ plugin to do this refactor for us. And before we go into the code for that, let's see if we can get a quick demo. How do I get there? Okay, this is maybe a bit bigger than I expected, but so this is a very simplified version of our abstract class. we are not looking at annotation here just to simplify this. So here we have just an abstract class, but it looks basically like an Autovalue class. And here we have its usage, a simple usage in Kotlin, just combines the name with the age and returns a string. And here we have the usage the same usage in Java. Well, it's cutting, but it does the same thing. So it formats and returns username, then comma age. So if you go back to the user class, and then we have the plugin action example, convert to data class, hopefully, yes. We get now our data class, our abstract class converted to data class. And in Kotlin, they are now a field. They're not anymore an abstract method being accessed. And in Java, we have the user get name and user get age, which turned out to be, developing this turned out to be simpler than expected, and so the results were quite good. So we were very happy that this worked out and simplified the migration process for us. So how does this plugin work? The entry point for a plugin, in this case, is an action, right? So the user is tapping on the menu option to make the conversion. So when that happens, we get this call on the action performed event in our plugin. And this is a simple boilerplate code that we can add to start the refactoring. So this is a simple example. So we look into a simple example here where we first get the current file that is open. And that returns a PSI file. A PSI file is basically an interface that IntelliJ provides for us to navigate through our code in that file. And once we have access to the file, we can navigate the source code via a tree visitor, which then has different methods we can override to visit different elements in our code. So here, for example, every time the visitor encounters a class, it's going to call back on this visit class function. And then what we can do with it is have a write command action where we can write some code or make some replacements or some refactoring and so on in that class. So in our case, we want to convert from abstract class to a data class. What we do here then is check if it's not a data class, and if it's not, and again, we're simplifying things here, we're not doing all the checks we should if we're publishing this plugin on IntelliJ. And if it's not, we can add the modifier data keyword to make it a data class. And if it's abstract, we remove the abstract keyword. Next, we have the visit name function callback, where we can also run commands to then change the names of our methods. So here we have, we want to change the users, like the colors, the name of the colors of our methods. Since we are changing, we have an abstract call, a method, for example, named age, and we want to make sure that the Java colors are now changed to get age instead of just age. So here's what's happening here. We use this reference search to find the usages of this function, and then for each user of this function, we call this handle element rename to rename it to get age instead of age. This works well for Java, but for Kotlin, what we want to do is change the type of call. So we are not anymore calling a method, we are calling a field. So for Java, for Kotlin, what we need to do is check the language of the element. So if it's Java, we can do the handle element rename that we're doing. If it's Kotlin, however, we can take advantage that this is an abstract syntax tree, basically, of our code, right? So we can get the parent of the method name that is being called, because the parent represents the name of the method plus its parameters, and replace it with the field name that we are creating in our Kotlin data class. And that's what we are doing here. So we are getting the parent, and we're replacing it with this new expression that we're creating based on the name of the parameter we are adding to our data class. And that's basically the gist of it. If you're interested, the source code for this example, the full one that works like I showed before in the demo, is available at this address. If you're more interested in IntelliJ plugins, here are some more links. I will publish these slides later so you can access them. One last thing that we did with our data class in our project, because we wanted to keep compatibility with Java, we still had Java classes, we're not migrating everything to Kotlin straight away. So we kept the with methods that we had, because in Java you cannot use copy out of the box for one single transformation. In Java you have to transform all the methods if you want to use copy. So it was easier to just keep the with that we had already for our Java classes and wrap copy inside with the information that we wanted to change. And similarly for the create, we wanted to keep the create for the Java users, for the Java callers, so we just annotated them with JVM static so that we could access them from Java. Finally, just a short notice on tests. We had a lot of tests already for parsing our classes. And it was very helpful to ensure that everything was working as intended once we finished the transformation. So it helped us ensure the correct serialization and deserialization of our classes. It helped ensure that the conversion of the methods were correct. And in some cases, it was good to have Mockito now supporting mocking final classes, because in Kotlin everything is final by default. And in a few cases we needed that, and it was helpful to have Kotlin support it. So in the end, we had these 46 Autovalue classes in our project that we converted to Kotlin. These Autovalue classes, they were generating these extra classes and these 500 plus methods. We got rid of 4 dependencies. We added one, the Gson value. Because annotation processing was happening less now, we had less plugins, we were not using Autovalue anymore, our build time improved a lot. The clean build was more than a minute faster, and the incremental builds when changing one of these classes improved a bit, not as much, but still was a significant change. The APK size remained the same because the Autovalue is done at compile time, so we didn't change much on the APK other than the additional classes that we didn't have anymore. And because of the mixed serialization approach, the startup time increased a bit, but we were okay with it. We are hoping with, to replace Gson with Kotlin X serialization, and then measure this again to see how it helps. And with that, I thank you. I think I was a bit early. Sorry, I was a bit fast, maybe. But any questions?
No worries. First question.
Yeah. So you show how to do how to migrate from Autovalue to data classes.
Yeah.
But I'm working for a library, and I'm used to provide some builders to allow them to allow my clients to use the builder so create the classes in an elegant way. For the data classes in Kotlin, what I have seen is you have to create like a class inside and do everything by your hand. Do you know there is a better way to do it, or that's the only way that is possible?
You mean other than having a builder for your data class?
Yeah. So.
Could.
So the way that, as far as I know, the way that Kotlin provides is you create a class inside your class. Example, this is you have the
like the companion object, you mean?
Yeah, you also other than the companion object, you need to create a class inside your data class. No, you need to create a class called builder.
Okay.
In this class, you are putting all the values to make a builder, and you are making the builder by your hand.
But I don't know if I get why you need to do that, because I mean with data classes you can just call the constructor directly, right? And if you need default values, you can just set default in the data class field.
It's because I have I also have Java code. It's not migrated only. So.
Yeah, but and then you need to do something like this, right? You need to have some kind of create function that creates with the defaults, or like some kind of yeah, you need to do like a builder like you do in Java. That is.
Yeah. Okay. Yeah. There is no way. You
I
need
don't
to do
think
it by
there is
hand, right?
I'm not aware of a way to get out of that.
Okay. Thank you.
Yeah.
Thanks.
Hi, thanks for the talk. Just one question. When you use Moshi to pass the JSON data, you can use all the features Kotlin provides, like constructor, default parameters, and so on. Do you also have this with Kotlin.serialization? Or is it possible to set it up somehow?
I believe so. I didn't test Kotlinx for that specifically. Okay. We tested this with Gson, and with Gson it doesn't work. Yeah. Because it's actually Gson is using a trick with the unsafe package of Java. So if you're using the default methods, it's going to fail. Unless you annotate all your fields with default, then it works because it becomes a constructor. Or you can do like an extra constructor in your data class to provide it as with the default values. Then it works with Gson, but with Kotlinx, I'm not sure. I would say yes, but I didn't test.
Okay, thanks.
Yes.
Hey, thank you for the talk. Just one question: why haven't you choose Moshi instead of Gson?
Because we had Gson in the project already with custom adapters in different places, so it would be a bigger change, and we are hoping to migrate to Kotlinx.serialization once it becomes more stable, and then we can. So, I mean, this is a bigger talk. We are hoping to have a common Kotlin module that we can share between Android and iOS, and we are hoping the case serializer can be part of this solution. And so we didn't want to do a two-step migration, and Gson was already working for us, so we didn't feel the need to migrate to Moshi, to then migrate a second time to case serializer.
Yeah, I got what you mean about this case serializer. Isn't it in beta still?
It's in what, sorry?
In beta?
I mean, yes, so it's marked as experimental, but I mean, it's already working, and it works already for different use cases. In February, when we finished this migration, we didn't start adopting it because of the performance. So we had concerns with that, but they were quite fast and responsive to do the work to actually improve it and to make it reach the levels of Gson and Mochi. Okay. And so now we are looking at it again, but probably in another talk. We may talk about it again.